Okay. So what we did in this lecture was we start with lecture 4, right? This is we have 4, 5, and 6 lecture for our exam 2. So let's start with lecture 4 here. What we discuss in this lecture?
The volume and capacity and the dead space and I think alveolar ventilation.
Right. So the major things which we talked about in this lecture, the major objectives we want to learn from this lecture are the 4 volumes and 4 capacities. We should know their definitions. Okay. So we should know their definition. Then we discuss dead space volume. So 3 types of dead space we discussed. We should know that. The next thing which we want to know is what is pulmonary ventilation and how to calculate. You should know how to measure pulmonary ventilation. Second thing, we discussed alveolar ventilation. You should know the definition of alveolar ventilation and how to calculate alveolar ventilation. Clear? Any difficulty till this part?
No.
Okay. After that, we discussed the last and very important thing was FEV1 and FVC. You should
The
know the
common test.
definition for both FEV1 and FVC. So you should know the definition. Let us go ahead and see the slides here. Can you see this is our first slide?
Yes, sir.
Yes, Doctor.
Okay. So let us go ahead and see the first 4 volumes and 4 capacities. Can somebody tell me the definition of tidal volume?
Simply breathe.
Okay,
Simply.
this is what is going to happen from this slide till the end of all the 3 PowerPoints. I'm going to ask very fast, very important questions. You should answer. You should note down what is important. Okay.
Okay.
And somebody should be answering. I want answers from 2 or 3 students so that I know that you have learned that. Then only I'll go ahead. Okay.
Okay.
Yes, anybody, not only one person, different person should be answering. Okay. It is good. It is good. You should answer. And whoever answer is revising, even if it is wrong, revise now. Make mistakes now. Okay. So that you don't make mistakes in exam. So let us start with the questions here. What is tidal volume? In one breath, right? Very good. How much is the normal value? Okay. Then we have the second volume is inspiratory reserve volume. Then we have third one is expiratory reserve volume and residual volume. What is residual volume?
The volume remaining in the lung after the maximum expiration.
Very good. Can you remember this definition? The amount of air remaining in the lung after maximal expiration. Okay. Easy to remember, all of you?
Yes, easy.
Similar definition is there for another thing. I'll tell you the definition, tell me for what it is. Okay. Volume of air remaining in the lung after normal expiration.
Functional residual capacity.
Functional residual capacity. Very good. So remember this difference. Volume of air remaining in the lung after maximum expiration is
Residual volume.
residual volume. Volume of air remaining in the lung after normal expiration is
Functional residual
functional residual capacity is made up of
expiratory reserve volume and
Residual volume.
expiratory reserve volume and residual volume. Please remember that functional residual capacity is made up of expiratory reserve volume and residual volume. Okay, please remember this. Okay, let us go ahead. What is vital capacity?
The maximum of air can be expired after the maximum of air can be expired.
So volume of air that can be expired maximally after taking maximum inspiration. So first you have to take maximum inspiration, then you have to expire. So that is our vital capacity. Please remember that. Okay, so this is the graph showing you where is tidal volume, inspiratory reserve volume, and expiratory reserve volume, and residual volumes. So this is the graph it is showing. Okay. So these are some other slides explaining you how the procedure is done, what are the instruments used. Now we come to the next concept. Any difficulty till the first part? 4 volumes and 4 capacities. We have discussed the most important one. Any difficulty
All
till
clear.
now? Clear? Okay. Now the second part from this lecture. What is pulmonary ventilation? Quickly somebody. What is pulmonary ventilation? 1 minute. What is minute ventilation?
Same thing.
The
Same
same.
thing. Very good. Okay. A person is having tidal volume of 400 milli and respiratory rate of 10 and dead space of 150. How much is pulmonary ventilation?
150 minus 400 multiply 250 to 12 to 10. Sorry.
Okay. The respiratory rate is 10 and tidal volume is 400 and dead space, anatomical dead space is 100 fakat.
100.
Yes.
So 300 multiply 12 multiply 10.
Habibi, you are very good student. You have tried very nicely, but you have one confusion. Can you tell me what was your mistake here? What is your confusion?
I know the you mean the alveolar ventilation, right?
Aiwa, you are telling me the answer of alveolar ventilation, not pulmonary ventilation.
I
I
talk
gave
about
you dead
pulmonary.
space volume in this question just to confuse you, right?
Okay.
This is what I want all the students to remember. When pulmonary ventilation is asked, you don't have to minus anything. You simply multiply tidal volume with respiratory rate. Can all of you remember?
Yes, doctor.
Okay, so remember this. Even if in this question where pulmonary ventilation asked, even if anatomical dead space is given, you don't have to minus it. Okay, in pulmonary ventilation. So what is the answer for this question? Here the question was tidal volume is 400, anatomical dead space 100, and respiratory rate 10. How much is
4,000.
pulmonary ventilation?
4,000.
400 multiplied by 10, yani
Yes.
4,000. Are you clear now, all of you?
Yes.
Yes, doctor.
So now you know in pulmonary ventilation, you don't have to minus anything or subtract anything. Simply multiply tidal volume with respiratory rate. Very
Yes.
good. Okay, next question. Next question. What is alveolar ventilation?
Amount of air you take in a in a minute that actually reaches the alveoli.
Exactly. Here, the amount of air reaching the alveoli and exchange area, nearby area, respiratory zone. So total amount of air reaching the alveoli and adjacent area is called as alveolar ventilation. So this is the first thing you have to remember. Now this pulmonary ventilation and alveolar ventilation are very important, especially alveolar ventilation. Therefore, we are giving more time to this topic. So remember the definition here. Alveolar ventilation is total amount of air reaching the alveoli or adjacent gas exchange areas. Okay. This is the definition you have to remember. Can you remember?
Yes,
Yes.
doctor.
Okay, so this is the first thing. Second thing, whenever you are asked to calculate alveolar ventilation, in this you have to minus
Dead space.
dead space volume from tidal volume. You see VD in the formula, you can see here, this VD is nothing but dead space volume. And this is tidal volume. Can you see the highlight I am making on the slide? Yellow
Yes.
color. You are able to see?
Yes.
Okay. So now my question is, How much is the alveolar ventilation of a person whose tidal volume is 400, dead space volume is 100, and respiratory rate is 10? Calculate.
3,000.
3,000.
3,000, somebody said. Anybody else? Any other answer? All of you say 3,000? Why? What do you
Can you
write
repeat the
here?
question?
What do you write here?
400.
400. What do you write here?
100.
100. And here it was
10.
10. So 400 minus 100 was 300. 300 multiplied by 10 was 3,000 milli. Okay. This is how you got 3,000 milli as the answer. Can you remember the formula and where to subtract?
Yes.
Okay. So
Sorry,
which
Doctor.
ventilation you subtract dead space volume?
Alveolar.
Alveolar ventilation. Okay. Please remember this. Can you say this sentence completely? When calculating alveolar ventilation, we need to subtract dead space volume from tidal volume. This sentence, can you say in Arabic for me? Yusuf Idris?
لما نحسب الالفيولار ventilation ننقص ال dead space من ال tidal volume.
Ahsan. Shukran, Yusuf. Okay.
Doctor.
Please remember everybody. Any question here? No question? Okay, now we come to the next concept, that is dead space. What is dead space? So somebody tell me, what is anatomical dead space? Definition.
The
Okay. Just to remove the confusion, you give answer right. Just to be very clear for all the students, let me repeat it. Anatomical dead space is the amount of air that remains in conducting zone, trachea and bronchi. Okay. Air that remains in conducting zone, yani trachea and bronchi. It will not go to alveoli, it remains. Okay. So that is anatomical dead space. How much is the normal number?
150.
150. Very good. Please remember this. Now, second, what is alveolar dead space? It is amount of air reaching the alveoli. It reaches the alveoli, but does not take part in gas exchange. Okay. Amount of air reaching the alveoli, but does not take part in gas exchange. So this is the air which is going to alveoli, but it will not take part in oxygen and carbon dioxide exchanging with the capillaries. It will not take part. Okay. So is it there in the normal person? Is it present in normal person?
No.
No. So how much is alveolar dead space in normal person?
0.
0.
0 milli. Very good. Please remember this. This in normal person is always 0 milli. Okay. Okay.
So
Okay.
Now, what is physiological dead space? How much is that?
Same
anatomical
anatomical.
Anatomical plus physiology, anatomical plus alveolar is equal to physiological dead space. Okay. How much is physiological dead space in normal people?
150.
Same as anatomical dead space. So in healthy persons, the anatomical dead space is equal to physiological dead space, yani 150 milli normally. Okay. So we use this to calculate alveolar ventilation, which we have already seen. Any difficulty till this part? Anybody has question? No questions? Okay. So now we go to the last important concepts, related to this lecture. That is FEV1 and FVC. What is FVC?
The volume of air can be blown out after full inspiration.
After full inspiration. So first you have to take maximal inspiration, and whatever you can breathe out is vital capacity. Okay. So that is force vital capacity, same as vital capacity. Now, what is FEV1?
The amount of air you forcefully expire within the first second.
Within the first second during maximum breathing out, यानी FVC maneuver, FVC procedure, maneuver यानी procedure. Can you remember maneuver यानी procedure? All of you?
Yes.
All of you?
Yes, yes.
What is maneuver?
Procedure.
Procedure. Okay. So when you are doing procedure for FVC, so when you are breathing out, whatever air comes out in first second is called as FEV1. Okay. Clear? And how much is the normal FEV1?
80%.
80% of
80% of the
FVC.
total FVC should come out in first second. So this is the normal. Okay. FEV1 out of FVC should be 80%. FEV1 FVC ratio should be 80% normally. If it is less, yani person is having obstructive lung disease. Can you remember?
Yes.
Yes.
Okay.
Yes, doctor.
Okay. So very important to remember here is the definition for vital capacity, and very, very important to remember is the definition for force expiratory volume in first second. Okay. So it occurs during FVC maneuver. Please remember the definitions here. So the normal is FEV1 should be 80% of force vital capacity, FVC. Okay. And in which condition it is decreased?
Obstructive lung disease.
Obstructive lung diseases. Example is bronchial asthma. Now remember 2 or 3 examples of obstructive lung diseases. Can somebody tell me example of obstructive lung disease? Okay, very good. These 2 are good enough. Emphysema is also obstructive lung disease. Okay. Sorry, bronchitis. Okay. Remember all those names. Bronchitis, COPD, asthma. These are all there. So any difficulty in this lecture?
No, doctor.
Okay, shall we move ahead to next lecture?
Yes.
Yeah.
Let me open. So our next lecture is this slide. Can you see the slide?
Yes, doctor.
Okay. So this next lecture is about gas exchange. The major objectives for this lecture were to know how gas exchange, yani oxygen and carbon dioxide exchange occurs between alveoli and blood. Okay, so that was our major objective in this lecture. That is what we tried to understand. So we saw how oxygen is diffusing into the blood and carbon dioxide is diffusing from blood into the alveoli. These were the 2 things we saw, and for this it was very important to understand which factors affect gas exchange. Okay. So these were the things we learned. To understand that, we needed to understand the pressure and respiratory membrane. Okay. So this was our complete lecture. Let us see. And also the last and important thing is diseases affecting diffusion. So these are our 5 major things which we discussed in our last lecture. Let us see some of the important things. What is partial pressure of a gas?
Particular gases excrete independently to mixture of gases.
Okay, so it is a pressure. Partial pressure is pressure exerted by a single gas or individual gas in a mixture of gas. Okay, So our oxygen is present in air. Yani air is a mixture of gas. So oxygen, how much pressure it is exerting in that air? It is 160 roughly. So that is partial pressure of oxygen in air or atmosphere, 160. Can you remember this?
Yes.
Okay. Quick questions now. Partial pressure of oxygen in atmosphere.
160.
160.
Partial pressure of oxygen in alveolar air.
100.
100.
100.
100. Okay. Partial pressure of carbon dioxide in atmosphere.
0.3.
Okay. Okay, but this one is more important. Partial pressure of carbon dioxide in alveolar air. How much is the partial pressure of carbon dioxide in alveolar air?
40.
40. Very good. Okay. So we'll see some more number ahead. We'll go to that. Okay. Okay. What are the different factors which affect diffusion?
Surface area.
Surface
For
area,
the
then
pressure.
concentration gradient, then
Solubility.
diffusion constant, which is made up of solubility and molecular weight, and then we have thickness of membrane, right? So these are the major factors which affect diffusion. Okay, so I'll tell you the summary. Rate of diffusion, let me go back. Rate of diffusion is directly proportional to surface area, concentration gradient, diffusion constant, and inversely proportional to membrane thickness. This is called as Fick's law of diffusion. Okay, clear?
Yes.
Clear, doctor.
Okay, now second thing to remember about these factors. What will happen to diffusion when there is increase in surface area?
Increase diffusion.
What will
Increase.
happen to diffusion when there is increase in concentration gradient?
Increase diffusion.
Increase diffusion.
What will happen to diffusion when there is increase in membrane thickness?
Decrease.
Decrease in diffusion.
Decrease. This is the only thing which will cause decrease. Whenever there is increase in membrane thickness, there will be decrease in diffusion rate. What will happen to diffusion when there is increase in diffusion constant?
Increase.
Increase.
Increase in diffusion constant will cause increase in diffusion rate. Very good. Okay. Now my next question is, what will happen to diffusion when there is decrease in surface area?
Decrease diffusion.
Decrease.
Decrease in surface area. Decrease.
Decrease in diffusion.
Decrease in diffusion. Very good. Can you give me any disease where there is decrease in surface area?
Emphysema.
Emphysema. Can you
Asthma.
remember this, all of you?
Emphysema or
And asthma,
Emphysema
right?
is decrease in surface area that causes diffusion decrease. Okay, can you remember this?
yes.
Okay, we'll see some more diseases in our last slide. Before that, there are other numbers which are important for you to remember. You already told me the partial pressure of oxygen in alveoli. How much is that?
100.
How much is the partial pressure of oxygen in arterial blood?
40. 100.
95.
100.
Okay, 195. Takriban, same. Okay. How much is the partial pressure of oxygen in venous blood?
40.
40. Can you remember these three numbers? Partial
Yes.
pressure of
Yes.
oxygen in alveoli is 100. In arterial blood, same, yani 100. And venous blood, it is less, yani 40. Okay. Can you remember this? Numbers?
Yes.
Very important for you to remember. Okay. Now we come to carbon dioxide transport. Okay. So where is carbon dioxide transport numbers?
After the slide of oxygen.
After the slide of oxygen? Yes, here? No.
No, after go down, doctor.
Okay.
After this for oxygen and after it for CO2.
Okay, here.
Yes.
Okay, but there should be one more slide which I don't see, but the numbers are there. Now my question is, how much is the partial pressure of carbon dioxide in alveolar blood?
40.
40. How much is the partial pressure of carbon dioxide in arterial blood?
40.
Okay, forget about this name, okay? It will confuse you. So remember, if you don't know, write it down. Partial pressure of carbon dioxide in arterial blood is 40. Partial pressure of carbon dioxide in venous blood is
45.
45. Can you remember these three numbers?
Mhm.
Carbon dioxide partial pressure in alveoli is 40. Carbon dioxide partial pressure in artery is 40. And carbon dioxide partial pressure in venous blood is 45. Can you remember this?
Yes.
All of you? Yusuf, once again, please help me.
Can you repeat, doctor?
Yes, that's what I'm asking Yusuf to do. Yusuf?
Yeah.
Doctor,
Yes, please.
can you go on the slide above it?
This one?
No, above it. Yeah,
This
here.
one?
Here it's clear. The venous 45 and the artery is 40.
Okay, but it is showing tissues here. Therefore, I
Doctor,
did not want to confuse you.
go
So what I will
another
do is
next
I'll
slide.
write it down. Is it okay?
Doctor, it's right in the slide here, in the same slide. First two line.
I'll write it down. I'll write it down.
Okay, no problem.
Okay, this will be easier. Let me just get out of this slide. How to end show? Discard. Now, can you see?
Yes, sir.
Okay, let me. You are still seeing the slides, right?
Yes.
How to enter the text here? Okay, here is a text box. Okay. So PO2, no, sorry, we are talking about CO2, right? In alveoli, how much?
40.
Right. Okay. Control C. Now we go to POCO2 in artery. Okay.
Mhm.
Right. Any difficulty here? Is the answer right or wrong?
Right.
How much is the answer here?
45.
45.
45 millimeter of mercury. Now, is it clear to all of you?
Yes, doctor.
Can you remember this?
Yes, sir.
So this is, let us say in alveoli. So I will make it blue. Artery blood is normally shown as red, right? And venous blood is shown as again blue normally. So we'll say can you remember this way? All of you?
Yes, clear.
If you are not clear, just take the picture and then we'll memorize it later. You can if you want. Taken?
Yes.
Yes,
Okay.
sound good.
Okay, shall we go ahead? Next slide.
Yes.
Okay. What is the normal diffusing capacity for oxygen?
1. 21.
21 milli. Please remember this sentence. The diffusing capacity for oxygen under normal condition is 21 milli. This is the one number you heard. This is diffusing capacity. If you see this number word, then only the answer will be 21. Okay. This is one thing you have to remember. Okay. Quickly. What happens in emphysema? Diffusion.
Decrease surface area.
Decrease surface area, therefore diffusion decreases. What happens in fibrotic lung diseases?
Increase membrane thickness.
Therefore diffusion
Therefore,
decreases. Very good. Increase membrane thickness. What happens in pulmonary edema?
Increase diffusion distance. Therefore,
Yani membrane thickness increases. Same. Okay. Can you remember this? Pulmonary edema also membrane thickness decreases. Therefore, diffusion decreases. Can you remember this? All of you?
yes.
Okay.
Yes.
دكتور البلمونر edema increase or decrease thickness?
Decrease. Pulmonary edema, the membrane thickness increase and diffusion decrease. Okay. Any confusion here? Because this is what is asked.
Fibrotic lung
Always.
disease also decrease membrane thickness.
Yes, same as fibrotic lung disease. Okay. Where is text box? Okay, here. So here it is. What is happening is increase membrane thickness. Okay. Therefore, diffusion decreases. Right? Same applies to pulmonary edema also. Here also. Okay. Clear?
Yes.
Yes.
Okay.
Yes, clear.
What is happening in emphysema?
Decrease surface area.
Decrease surface area. Okay, right? And what happens in asthma?
Same emphysema.
Same thing. Asthma causes blockage of bronchi that causes no air going to some part of the alveoli and a decreased surface area. Okay. Decreased surface area, therefore diffusion decreases here also. So remember this, always ask one of the disease. Okay. What happens there? Always ask. Please remember this. Can you remember this?
Yes.
Okay, doctor.
Clear? Okay.
Yes, clear.
Okay. So what we are going to do is now, this is all in this lecture now. Okay. We have finished this lecture. Any question you have? We have 2 minutes for this schedule to stop this Zoom. We'll start again for the next lecture. You have any question in this 2 minutes from these 2 lectures? No question?
Clear, doctor.
Okay. So we stop here. And we'll start again, same PowerPoint, same link. Okay, same Zoom. Because the time is ending, we'll start a new one. We'll end it now.